Ionic bond. In the first video we have seen what are the different types of bonds. Number one is ionic bond. Second one is covalent bond. Covalent bond. Third one is coordinate bond. Fourth one is metallic bond. Last time I told you metallic bond we'll study in solid state in +2. Okay, so this we are dealing these three substances. Okay, so first one is ionic bond. Ionic bond. This is the Coulombic force of attraction. If you see the formation of NaCl, this is plus, this is minus, right? So this is the electrostatic force of attraction which binds the oppositely charged ions. That is called ionic bond, right? So let us write what is ionic bond. It is a Coulombic force of attraction or electrostatic force of attraction. Force of attraction which binds the oppositely charged ions. Okay, so first one, let us see what is how the ionic bond is forming, what are the conditions for ionic bonds. So first one, ionic bond is formed between electropositive element plus electronegative element. Electropositive element and electronegative element, it gives ionic bond. So ionic bond is formed between electropositive element and electronegative element. Okay, first one is, then what is the conditions? Conditions for formation of ionic bond. Ionic bond. Number one must be one atom must be electropositive, while other must be electronegative. So one element must be electropositive, other must be electronegative. Second one is there should be high difference of electronegativity between the atoms, between the elements. Okay, then third one, cation must have low ionization energy. Anion must have high electron gain enthalpy. Okay, then fourth point. So fourth point is they must have high lattice energy or they must have high lattice enthalpy. Third point is they must have high lattice enthalpy. Okay, so what are the conditions? Number 1, electropositive element and electronegative element, they form ionic bond. So electropositive element must be cation, electronegative element must be anion, right? The electropositive element must have low ionization energy. Electronegative element must have high ionization energy. Then there should be difference, there is difference in electronegativity, means high difference of electronegativity between these two atoms or elements. Then they must have high lattice enthalpy. Okay, what is lattice enthalpy or lattice energy? Lattice enthalpy, I'll tell you, lattice energy is the amount of energy required to break the solid ionic compound into gaseous ions. I'll write this one. Suppose for example NaCl. This is ionic compound, this is solid. Okay, you are giving energy, you are applying energy here. So it is converted into Na plus gaseous ion plus Cl minus gaseous ions. Okay, that is called lattice enthalpy. The amount of energy required to break the 1 mole of solid ionic compound into its gaseous ions, Okay, so first one, Na plus and Cl minus, right? So in NaCl. Next one, what is the factors affecting lattice enthalpy? Okay, it's a very, very important point. You may get in even the very S block it will come, P block it will come, even there are questions from entrance questions also there. Okay, they look simple, but when questions come, we will not be able to answer it. So lattice enthalpy, factors affecting lattice enthalpy. Students, just we have seen what is lattice energy, right? Or lattice energy or enthalpy, both are same. So normally we call it energy. In chemistry we call it enthalpy. So lattice energy, what are the factors affecting lattice energy or lattice enthalpy? So lattice enthalpy is K Q1 Q2 by R. That means see here, lattice enthalpy is directly proportional to charge Q1 and Q2, and lattice energy is inversely proportional to R. R means R plus and R minus. This is for cation, this is for anion. Okay, so lattice energy is equal to K. K is constant. Q1, Q2, we take, suppose for example NaCl. This is charge of cation, charge of anion. Then what is R? R radius of anion and radius of cation. Okay, so lattice energy is directly proportional to Q1 into Q2, and lattice energy is inversely proportional to R. R is R plus and R minus. Okay, so just first factor is size of ions. Okay, first group if you take lithium chloride, lithium, sodium, potassium, rubidium, cesium. So chlorine. Okay, here what we can see, This chlorine is constant here. Lithium, sodium, potassium. So how lattice energy? When you move from top to bottom, lattice energy decreases. Lattice energy decreases. When the size increases, you see here lithium, sodium is lithium, sodium size is bigger than K, then rubidium, then cesium. This is plus, 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 plus. The size of the cation increases, so the lattice energy decreases. Next group, if you see beryllium, magnesium, calcium, strontium, barium, here chlorine, chloride, Cl2, Cl2, Cl2. Here also the size increases. Size increases. So what happened? Lattice energy decreases. Okay, size of ions. Second one is, so here size of cations. Okay, here. So next, size of anions. So anions also, when the size increases, so what happened? Lattice energy decreases. So if you see K, F, KCl, fluorine, chlorine, bromine, iodine. Here K is common in everything. Cation is common. Fluorine, chlorine bigger, Br still bigger, iodine is the largest one. So size of anion increases. So lattice energy decreases. So decreases, how will you write? Lattice energy decreases. Decreases. Okay. Next one. Second one is charge on ions. Charge on ions. Okay. So how will we can find out charge on ions? If you take magnesium chloride, then sodium chloride, okay, aluminum chloride. Here you see sodium plus 1 charge, magnesium plus 2 charge, aluminum plus 3 charge. So when charge increases, when you move from left to right, charge increases. Charge on cations increases. So lattice energy increases. Lattice energy increases. Okay, next one, another example. Suppose KF is there, CaF2 is there. So here plus 1, here plus 2. So this will have high lattice energy. This will have less lattice energy. Okay. So lattice energy, first let us see what is lattice energy. Lattice energy means the amount of energy required to break the solid ionic compound into its constituent gaseous ion. Constituent means suppose NaCl, Na plus and Cl minus. Okay. So next one we will study what is electrovalency. What is electrovalency? Electrovalency is when a ionic compound is formed, the number of the charge, what is the charge it loses? For example, NaCl. This loses 1 charge, so plus 1. This gain 1 charge, this is minus 1. So electrovalency is the charge it loses or gains. Okay, for sodium electrovalency is 1. Chlorine electrovalency is 1. So it is just a number. you see here, children, you see valency. You might have studied in 9th or 10th. What is valency? Number of electrons gained or lost or shared during chemical combination. So valency, we know this one. In case of ionic compounds, we use the term electrovalency. What is electrovalency? Number of electron lost or gained, okay, during the bond formation. Which bond formation? Ionic bond formation. So here Na, it loses one electron, so 1. Chlorine, it gains one electron, so it is 1. Just it is a number. So in case of, for example, calcium fluoride, so it loses 2 electron. So 2, 8, 2. So calcium's electrovalency is 2. Fluorine 2, 7. It gains 1 electron. So this electrovalency is 1. Don't get confused, okay? So for ionic compounds. But in covalent compounds, we call it covalency. That we call it covalency. Covalency means number of covalent bonds formed in the compound. Covalency is number of covalent bonds formed in the compound. For example, ammonia, CH4, we can take CH4. So CH, H, H, H. So here how many covalent bonds are there? 1, 2, 3, 4. So carbon covalency is 4. For hydrogen, how many? Only 1. So hydrogen covalency is 1. Is it clear? Okay. Now we are going to see the properties of ionic compounds. Okay, one point. Normally we studied ionic bond is formed by highly positive, electropositive element and electronegative element. One exception is there, NH4 plus. This is the exception. Okay, there are so many compounds are formed by NH4 plus. For example, NH4Cl. So this we consider as plus, this we can consider as minus. Here this also non-metal. This also hydrogen also non-metal. Both are formed from non-metals. This is ionic compound only, but ionic compound is formed by 2 elements. Both are non-metals. Is it clear? Okay. Next, let us see what are the properties of ionic compounds. Dear students, so we have seen what is ionic bond. Okay. Then what are the conditions for formation of ionic bond? Then how it is formed, what is lattice enthalpy, what are the factors which affect lattice enthalpy. Today we will stop here. The remaining we will see in the next class. Okay, thank you.